Okay.
This is Physics 111. We are Group 1, Stephanie, Michaela, Amelia, Maya, and Magdalena. A general overview of the project. We started off by dropping a pumpkin in a coffee filter at the same time from the height of about 1.8 meters. And the weight of the pumpkin was 27.80, and the weight of the single coffee filter was 0.68 grams. And then we dropped the pumpkin in a stack of 7 coffee filters, and the 7 coffee filters weighed 4.80 grams. We wanted to have different masses for the coffee filter, but to keep it less than the mass of the pumpkin so that we could compare it to the time of the pumpkin touching the floor. Why we wanted to do the project, just a general overview of what free fall is. It's basically in the absence of resistance, all bodies fall with the same acceleration independent of their mass. With this project, we wanted to show how when air resistance is present, two objects will not land at the same time. This project allowed us to observe the difference in mass on an object in free fall by comparing it to a control, which is a pumpkin, and a varied one, which was tested at a lower mass.
So, as we studied in class lecture, we learned that Galileo stated and concluded that motion under the action of gravity has constant acceleration. Constant acceleration is defined as 9.8 meters per second squared. It is said if objects have equal acceleration during free fall, if two objects are dropped side to side, they will reach the ground at the same time. This is true if air resistance is not present. So in the first trial, what we did, we had two objects of two different masses, a pumpkin stress ball that was 27.80 grams and a singular coffee liner that was 0.68 grams. And the total amount that it took for both objects to reach the ground was 2.5 seconds. The pumpkin reached the ground at 0.7 seconds with an acceleration of 9.28 meters per second squared, and then the coffee filter was 2.5 seconds with an acceleration of 0 meters per second squared when it reached the ground.
Next, we added 6 more coffee filters to see if it would change the amount of time to reach the ground. The weight of the pumpkin was 27.80 grams, while the small stack of 7 coffee filters weighed 4.8 grams. As we have said, in the first trial, it only took 2.5 seconds for the 1 coffee filter paper to reach the ground, while it only took the pumpkin 0.7 seconds. Once we added more coffee filter paper, the pumpkin still only took 0.7 seconds to reach the ground, while the pieces of coffee filter paper took substantially less time than before and only took 1.2 seconds to reach the ground. The acceleration for the pumpkin trial was 9.4 meters per second squared, while the acceleration of the 7 coffee filters was 0 meters per second squared.
Okay, so terminal velocity, when an object is falling, gravity pulls it down, which is about 9.8 meters per second squared. Gravity and drag force affect a falling object. Terminal velocity is reached when the speed is constant. Terminal velocity will be different for each object because of the way air resistance can act on an object based on shape and surface area. So the faster you go, the faster the drag will get. When terminal velocity is 0 weight, then the drag it equals the drag force. In this experiment, we do not see free fall acceleration since the height from where the objects were dropped is very small. If we had dropped them from a higher height, then our data would have reached 9.8 meters per second squared.
So with air drag, the objects that fell at different times and had different accelerations than what was expected. Pumpkin stress ball was close to the expected value. The single coffee filter and the 7 coffee filters did not reach the expected values because of the drag force. In trial 1, The pumpkin did not reach terminal velocity, but was close to 9.8 meters per second squared for acceleration. In trial 2, the pumpkin was also close to the 9.8 meters per second squared, and it also did not reach terminal velocity. The single coffee filter and the 7 coffee filters did reach terminal velocity, and we had a discrepancy for the pumpkin in trial 1 of 5.3%, and pumpkin 2, and in the video 2, the pumpkin had a discrepancy of 4%. And the terminal velocity for them to actually reach it would have been if the pumpkin had a constant speed of 3.8 meters per second, and in video 2 would have been 3.1. The coffee filter is around 1, and the 7 coffee filters is around 2, which we did see, and which is why they had no acceleration.